Hi everyone. Today I'd like to present to you one of the most ambitious projects that I have attempted so far. So this is basically a plastic box, but it had been modified to have some additional material for a portable sampling box, and I have interested to measure the five particle and pretty much suspend this particulates in the ambient and indoor atmosphere. So I was bought some material in about in March, so it was 4 months ago. What I have done with this box right here is to add a grill. So this is stainless steel with I think it is 1 millimeter size or 22 mesh, and this on the exhaust I have a fence. This is the four cones that I took from a case, a Dell case, that had 4 Y. So this is Y from the fence. So the idea is to have this box with. Uh, Let me take the plastic box. So when it's closed, and this is the cover and lid, I can have the system to carry on my bike, my motorbike, and take the sample with run-out battery. So this is 4S battery, lithium battery, and or it can be plugged in at home to run some continuous monitoring. There are more sensors in this system, but I have took out to add to the second units. Now the basics setup for this one is I have this is phone, so I just this afternoon I just add some ports to this one to have more convenient access to the system. So basically I have one of the females DC in type for 12 volts in at the stationary, and another port for 16.84 to quickly charge the 4S battery if I need to recharge somewhere or need to quickly recharge at home. It have the 3 position switch to either engage the battery or put it off position, or to charge this when I have this power in this point. I also have multi voltage ampere meter and a quick switch to turn on and turn off the screen. Also in this side is the Raspberry Pi to take the to communicate with the sensor modules and storage data. Also in this area is some sensor, pretty much temperature and humidity. Also fans modulation control to turn on to increase or reduce the fan speed to the knob. So let's demo what it working. So first I have 12 volts wall plug, so I make sure that I have in the position. So if I probably gonna try to turn on the battery later, but let first plug in the battery. So you see it's not exactly 12 volts because to have in this side to have a switch between the main voltage, not exactly main voltage but DC drive from main voltage, and a battery. I have two big diodes at the EN 58 22. Let me try to, so this is the one N5822, so it's N5822. At the diode to pretty much you have this in this side I have the schematic drawn later, but the idea is you have either power come from the battery or from the wall plug coming to this side, and this gonna fed into this is 12 volt, maybe 28 volt, but it's gonna give constant 5 volt output to fit into an Arduino and a Raspberry Pi. Now this is what added this afternoon, but I have been thinking about this for some time. I tried to use a MOSFET earlier, but this is the most simplest way to have almost instant switch on and switch off. To demonstrate that, I am having 12 volts plug in, and you can see some of the reading here. We have 3 temperature sensor, which is input. So in this corner, so you can see one of the black wire right here coming on the front, and on this side you have it kind of dusty because it's measuring dust, but you can see probably this way you have a waterproof temperature sensor. This one, you also have the exhaust temperature sensor. It's just additional features that I want to have, so I know how much energy or temperature swing between the front and the end. There also another temperature. This one is the same type but not waterproof. This is BSE 280s, and another is SE, I think it's 7120 temperature humidity sensor combo. So the nice feature of this system is that it gives you a portable system that you can travel or spend at home, and you can place a lot of sensory module in here. And this one I have an this is ESP32 with the CCS811 to measure the equivalent CO2 and volcanic, but this sensor is not very reliable. More information maybe later in other posts. Another here is a green one is Plant Tower PMS 703, and this one is the black one with a pretty much rusty cover here is Nova Fitness RDS 11011. So you can see that I have the fans on. I can control the fan by turning this knob, and you probably see this one right here. Turn height can run up to 0.4 amps, and I can turn it almost off but not really off, close off. This doesn't hear anything from any noise from the fans. This is an additional feature to turn off the screen. That's only that this might save a little bit energy on the rise, or you want to be a low profile when monitoring. Just 2 position switch. Now the fanciest feature is this one. Now this one I have, you see this now is 11.7 volt because it's fitting 12 volt, and it have about 0.3 volts as the loss in 4 volt voltage to the diodes, the big diodes that you see, as you saw earlier. Now to engage the battery, I turn to its position, and you see quickly it's jumped to 15.3 volts. So if I pull out the 12 volts, you have the system running, and I can turn on the fan so you can hear some noise. Probably you have 100% here at the fan duty, and decrease, right? So I can plug it 12 volt in, and didn't get the battery, so it returned to 12 volts. The second feature with a quick charge port here is that I had modified a laptop charger and added a voltage control and voltage and current control to quickly charge the 4S. It's simple. This module can box up in eBay or AliExpress for $3 or $4. It's the step down voltage and current control, and also a male DC plug-in. So I'm gonna charge this one. So basically I just charge this, and you see this one doesn't have any currents because I have not engaged in charging. So to engage the charging, I need to use a switch and turn to charge, right? So I set up this for 0.5, 0.6 amp as the max charging current. So right now I have about 0.57 amp, which is what I want. I could turn up let me move the camera a bit, the phone actually. So you can see there are two notches, two potentiometers on this module that you can either increase or decrease the voltage and the currents. For me, 0.5, 0.6 amps for charging is safer because it's not actually a high quality battery. This is the battery. Let me try to focus on the battery that I took from one of my power banks from the Aluratex. They are market Samsung, 2000 milliamp hours at 3.7 volts, I believe. So I have about 800 milliamp hours at 3.7 voltage battery right here. So I'm charging them with 0.4. It has been fully 50 volts somehow, so it's not charging at the maximum current. So also I have this in this side I have a GPS module, but I want to demonstrate that okay, I have the battery plug. You can see the reds LEDs for the indicator of power. And also I want to quickly show you the setup on my computer to access them on the run. So I want to hold my phone so it's a bit shaky, but okay. So here is my Raspberry Pi. Let me focus here. So I name it as a field, but you can let me try to access the USB. So okay, it's not convenient if I need to tie for one hand, but DLV TTY U capital U S B star. Okay, so I have one USB plug-in, and that is from one of the PMS module. I can have the Python code to run its module to Raspberry Pi and collect the environmental sensor. It's not easy to do in one video, so I probably do it later time. It's a kind of long video. I don't think that 12 and 13 minutes video is good enough, but it's kind of like a lot more time to condense the material and speak in 5 minutes video without additional editing. So hope you bear with me, and maybe a thumb up if you like it. If you have other comments to improve, please let me know. Thank you.